Yeah, good morning, good afternoon, and good evening to you all from here in the UK. And we've got my colleagues coming in from the US as well shortly. Welcome to another Evening webinar. My name's Andy Tobin. I look after our business here in Europe. As you probably know, there's a lot of regular faces on here, but these webinars are focused on self-sovereign identity and digital credentials. And we run these webinars regularly to help you learn faster and build more efficiently. On our last webinar, we had a stellar panel with us who talked about health credentials, which is a topic that's all over the news at the moment. And just prior to that as well, we had Alan Murray Hayden from IATA talking about the IATA Travel Pass Initiative, which I think goes down as the most well-attended webinar we've done so far, which is obvious why, really, isn't it? And it's fair to say that digital credentials are attracting mainstream interest around the world at the moment, catalyzed by the COVID crisis. And rightly, the issue of privacy and confidentiality comes to the fore. So if you just joined, you didn't see the trailer there. On April the 14th, we have our next webinar, which is one not to be missed. It's with a special guest, Dr. Anne Kavukian, who's the creator of the whole concept of privacy by design. And she's coming to speak to you April 14th. So make sure you book that one, bookmark that one in your diary. So in this webinar, we're diving deep into the details. Many of the previous webinars we've had, if you've been on them, you'll know we have many, many more questions than we can ever handle. There's been lots of questions about the underlying technology. We've not had really the time to do them justice. And we've had lots of requests to go deeper. So you asked for it and you're going to get it. Here it is. Today, we're talking about BBS Plus. What is it and what does it mean for verifiable credentials? I'm joined today by cryptographic royalty. If you can drop to the next slide, thanks, Alex. My own experience in cryptography stopped at triple DES, and Brent is in a different league altogether. Brent wrote a blog post recently on evening.com/blogs/blog describing why the verifiable credential community should converge on BBS Plus. It's well worth a read, and it really, the interest in that catalyzed the need to put this webinar on. So Brent, could you just do a quick intro, please, for our audience?
Yeah, hi folks. My name is Brent Zundell. I've been working at Evernym for nearly 4 years now, and been knee-deep in crypto and verifiable credentials and anonymous things and privacy and standards and all sorts of stuff since that time. So it's been a lot of fun, and we're gonna have a lot of fun today.
Thanks, Brent. And you're co-chairing the W3C, the World Wide Web Consortium, right, working group as well.
Yeah, so one of the chairs of the DID working group, one of the chairs of the VC working group, and yeah, worked on some stuff at Decentralized Identity Foundation, doing a lot of standard stuff.
Yeah, thanks, Brent. And Brent, as you'll have detected, is very understated and modest. Also delighted to be joined by Drummond again as well, the architect of decentralized identifiers himself. Drummond, do you want to do a quick intro for us as well, please?
Very happy to, Andy. It's ironic in that I am not a cryptographer. I'm not a cryptographic engineer. I call myself a connoisseur of cryptography and cryptographers. And that's why I'm going to be the one launching all the hard questions in Brent today to pull out the key points of his blog post and his knowledge, which is, you have to do that with Brent, because otherwise he's just heads down, producing the code, producing the papers, producing the standards. And this is an opportunity for us to sort of pull out his knowledge and share it with folks. And I'm really excited about that.
Cool. Thank you very much, Drummond. So on the agenda today, really pretty simple agenda, actually. We're just going to give you a quick primer into 3 really simple concepts that are really important to understand. We attend a lot of webinars that other people give, and we read things, blog posts and opinion pieces and all that kind of thing. And it's often the case where people don't get some of this stuff right. So what we want to do is just make sure we all are up to speed on 3 basic concepts, because we're going to be referring back to them a lot in this session. So we'll be doing that. And then Brent is going to be quizzed intently by Drummond. And then we're going to open up to audience Q&A. So that's the agenda, simple as that, really. If you've got any questions, please put them in the Zoom Q&A. Okay, there's a Zoom chat, but the questions we normally like to take them in the Zoom Q&A. If you can do that, please. Alex in the background, our webinar wizard, will pull those together, and we'll go through as many of them as we can do after the session with Drummond and Brent. So if you can ask your question in the Zoom Q&A, that'd be great. Please note the webinar is being recorded as well. We do publish the recording afterwards. It'll be available on our website, evenem.com/webinars. So look out for that, and you'll find all the previous ones there as well. So without further ado, let's crack on. A quick primer for you on verifiable credentials and privacy on 3 specific areas: selective disclosure, compound proofs, and zero knowledge proof signatures. So let's crack into those. This is a really significant capability, that these 3 components I've just described, that underpin a lot of the principles around privacy that are built into the way that we've implemented verifiable credentials. So the first one we want to talk about is what's called selective disclosure. What do we mean by that? Well, it's a superpower that you get with digital credentials that you don't get with paper ones. Selective disclosure simply means you can take selected elements from a credential, so selective attributes, and only reveal those without revealing the other data in the credential. So in this example with a driving license, you might have, what have you got on there? Maybe 15 attributes. But in order to do a particular transaction, you only need to reveal 2 of them. So that's what we call selective disclosure. And in order to do this, you need to have a lot of the stuff that Drummond and Brent are going to be talking about in a minute. You can't really do this with paper credentials or passport. You show it to somebody and they can see everything. If it's a driving license, they're seeing your address, when all you want to do is, it's the old example of getting into a bar. Selective disclosure is all about the ability to pull out individual attributes from a larger credential. So you're only revealing what is important for the particular transaction you want to do. The second concept is compound proofs. So a compound proof is where you're taking attributes from multiple credentials and bringing them together into a single proof. Okay, so in this example here, you've got some information from the driving license and you've got some information from the concert ticket, 2 different credentials, but you're taking elements of information from each using selective disclosure, but you're compounding, you're bringing these attributes from different credentials, from completely different credential issuers together to create what we call a compound proof. You can do this without ever having to go back to the issuer, right? You can do it on the fly. When you're asked to prove something, your app will compute all of this for you automatically and provide a compound proof without revealing all of the other data on those credentials. So really, really powerful. That's what a compound proof is. So selective disclosure, compound proofs, vitally important. And also it demonstrates the flexibility of verifiable credentials. Done right, you're only sharing the minimal information you need to share, but you can combine different sources of information, which is often what happens. Like if you're onboarding to a bank, you've got 2 proofs of address from different utility companies and a proof of citizenship and so on. That's naturally what we all do. So compound proofs allows you to do that. And the third piece is getting deeper into the tech, correlating signatures. Okay. If when you prove something to a verifier, if you share the issuer's signature, then you're providing them all with a perfect correlator that allows everything you do to be correlated across those different verifiers you're sharing that information with. So when the issuer signs a credential, if they sign it with their signature, that signature they've signed it with is unique to that credential pertaining to you. So if you have to share that signature in order for the verifiers to check that that credential is authentic, you're sharing like a unique global super cookie, and all of those third parties that you're sharing with, they could collude behind your back. It's like a super version of a Google ad identifier, right? So correlating signatures you don't want to have. The way you want to do it is, instead of sharing the issuer signature, and go to the next slide, please, Alex. Instead of sharing the issuer's signature, what you do is you share a zero knowledge proof that you have the issuer's signature without sharing the signature itself. So every verifier that you're sharing information with, when you're providing a proof, you're not sharing the issuer's signature. Now, to do that is, as we'll find out in a minute, Drummond will ask Brent how this works. This is vitally important. The last thing we want to do with this whole new world of verifiable credentials is create some new global tracking economy. So the ability to share information that can be verified as authentic without sharing the issuer's signature stops you being correlated, and it also means the verifiers don't have to contact the issuer to verify anything, and therefore the issuer is blinded to what you're actually doing and who you're sharing your information with, which is how it should be. So those three concepts of selective disclosure, compound proofs, and non-correlating zero knowledge proof signatures are vital to getting digital credentials done right. And with that, I'm going to hand over to Drummond and Brent, because I think, Drummond, you want to dig into this with Brent a bit more on this particular bit about signatures, right?
Absolutely, Andy. First of all, you did a great job of describing why it's important. And Brent, in his blog post, goes into sort of the origin story. So I'd like to start with my questions to Brent about that. And Brent, would you back up and give us a little history? What was zero knowledge proof crypto always part of the picture for W3C verifiable credentials, or how did it come into the picture?
Well, those who've read the blog post know that my my beginnings with the verifiable credential community were rather abrupt. So I was, thrust into the group, not sure what standards were or how the process worked or any of that. I just knew that in order for us to be able to use the resulting standard that the group was building, we needed to have a zero knowledge proof story. I found ready support from the chairs of the group. They had wanted a good privacy story for verifiable credentials and had heard of zero knowledge proofs. So I got a lot of encouragement from them. And shout out to Manu Sporny, one of the primary editors of the verifiable credentials spec. I would write a PR and Manu would come back and go, now, if you want this PR to actually get into the spec, I suggest you word it this way. Without that help, zero knowledge proof capabilities wouldn't be represented in the verifiable credential spec today. So there was, to briefly answer your question, not really. There was some hopes for something like what they could provide. But, yeah.
Right. So this is why, or one reason, that the edition that you spearheaded and then others supported of adding zero knowledge proof credentials. But is this why there are several what people call flavors of verifiable credentials in the W3C spec?
Yeah, this is one of the flavors. The chairs of the group were really hoping to get some diversity of possible implementations. And so I recommend everybody to read a report from Kalia about the different flavors of credentials. If you haven't read that yet, it's a really, really good primer on what we're talking about right now. There was this, in the group, there was this kind of dichotomy between this highly interoperable LD signatures on one side, using JSON-LD, which is really powerful, provides good semantic meaning for what the credential attributes actually, what they mean. On the other side, we had our Kamenisch-Lisiensky zero knowledge proof capable signatures, very capable in reducing this unwanted correlation that Andy was talking about. Not only signature correlation, but correlation of the holder, the ZKP credentials don't require that the holder be given an identifier that's shared. We just want to put the ability to, basically the ability to correlate myself as a holder should be in my hands rather than as a side effect of the protocol and the credential format that we use. But there was no real way for these two sides to come together at the time, so we needed at least a couple different flavors, and the JWT credentials were in the mix as well.
And briefly, the JWT credentials, can you describe that third flavor briefly?
Well, there was the JSON-LD camp, and they had done most of the foundational work for verifiable credentials. We came in along with a couple of other parties to do the zero knowledge proof stuff. And there was a JSON only crowd that really wanted to take advantage of some existing formats. And so the JWT credential format was a way to try to bridge that, between verifiable credentials and the existing JWT methodology and format.
Okay, so basically, as Kalia's report describes, there have been these three major flavors: JWT and JSON-LD, and then the ZKP format. So let's now zero in on that ZKP format. I think you've hit most of them. But what are the reasons that Evernym originally proposed that, and that's been what we have focused our implementation on, and the Hyperledger Indian Aries stack explicitly supports? What are the main reasons for what I think has been called anonymous credentials?
Mm-hmm. So the original goal of anonymous credentials and of all of the tech that Evernym has built and tried to promote, we want power to be in the hands of the people who own the data. If the data is about me, I should be able to control who sees it, how much they see, and when. And so we looked for credential signatures that had the capabilities, that Andy mentioned. Selective disclosure is vitally important. If I have a credential and the verifier really only needs 2 attributes on that credential, then I shouldn't have to share all 25. And the verifier, most verifiers that we work with, they don't want to see those extra 23 anyway. They're recognizing more and more that this additional data doesn't really benefit them. Additionally, signature blinding is really important. Andy pointed out, it's revealing the signature is a perfectly correlating identifier. Any verifier that sees that can say, oh, yep, this is the signature. Hey, did you get the signature? Yeah, I got it. What information did you get? Well, let's share. Let's build up a better profile. Let's collaborate. It also prevents, one of my favorite aspects of anonymous credentials, they were originally designed to allow people to anonymously log into systems. So the issuer and the verifier in the original concept was the same entity. And they wanted to prevent the issuer from even being able to know exactly which individual was using the credential. The only knowledge that was passed back was, is this individual authorized to be here, yes or no? Okay, yes, they're authorized to be here, good. Then we don't have to know, precisely who they are and all of that. We can let them in. And we've been able to expand on that. CL signatures also provide link secrets for holder binding. This is a really important concept because many of the LD signatures and even the JWT credentials, they rely on a decentralized identifier for the holder. Now, decentralized identifiers are fantastic, but as a holder, I don't want the same decentralized identifier to be presented to a bunch of different verifiers. I don't want to provide another correlating factor. I want the power to correlate myself as much as I need to and no more. The other thing that CL signatures had that we really, really liked was the ability to do predicate proofs. So rather than if I have a credential from my bank of my current bank account status, I can share a proof that says, oh yeah, my account balance is higher than this amount. I'm not going to tell you what the amount is, but I can prove that it has that relationship. And predicate proofs felt really central to the capabilities that we wanted.
Absolutely, and with as you said, the Kamenisch-Lisenski signature format with anonymous credentials, we got all four of those things that you mentioned, and that's fantastic. Now, I'll point out Reuven Heck from the Decentralized Identity Foundation has pointed out privacy-preserving credentials are not needed all the time, right? There's certainly times where you're issuing a credential to, you know, an organization or a thing of some kind, and you don't need these privacy preserving properties that apply to people, and I totally acknowledge that. So we are talking about the set of use cases that affect when a person is issued a credential, especially something that might have sensitive personal data like health data that we're talking about with digital health passes. So Brent, of the four things you mentioned, we'll talk more about predicates later, but link secrets, it's always been at the heart of how anonymous credentials work, and yet there are a lot of misconceptions about link secrets. So Brent, what exactly is a link secret, and what is the problem that it solves?
So a link secret is just, it's a secret. Let's bring it back to DIDs. If I'm the holder of a DID, how do I prove that it's mine? How do I prove that I control it? Well, I have a private key and I can sign something with that private key and it can be verified. So the security that DIDs are based on is based on the holder knowing some secret. And I can demonstrate that I know that secret based on the architecture of the decentralized identifiers. Link secrets is exactly the same thing, but I don't have to share an identifier. I don't have to share anything that correlates me. I can still prove I know the secret, but I can do it in a way that doesn't allow that. If I prove to two different verifiers, I can do it in two different ways so that those verifiers can't get together and know that they've talked to the same person.
So what you're saying is, what Andy was talking about was not the ability to avoid correlation on the issuer signature, which of course the verifier has to be able to verify that the issuer actually issued the credential. But what you're saying is that link secrets allow you to avoid correlation on the holder signature to prove they have the credential. Is that right?
Right. Just as on the issuer side, you know, yeah, the verifier needs to know who the issuer is, but an issuer signing credentials, every single credential signature, especially with LD signatures, it's going to be a unique value. And the verifier just takes that value, does a little bit of math and goes, yes, okay, this works. With ours, we can reveal a different signature every time. The verifier still does a little bit of math and goes, yep, it works out, it checks out. They can still verify that the credential hasn't been tampered with, and they can still verify that it definitely came from that issuer. But similar with the link secrets, it's a way to do it that doesn't provide the correlation.
Right. So it seems that since what we need to avoid is to avoid this correlation, we need to avoid issuer signature correlation and holder signature correlation. Is the ultimate conclusion here that to avoid both of those things and avoid either one being a tracking beacon in your credential, the only option for privacy preserving credentials is to use a ZKP and link secrets?
Yeah, I think a lot of people are concerned about zero knowledge proofs. What zero knowledge proof really means, it doesn't mean I'm not showing anything. It means no information is shared beyond what I want to share. The verifier gets zero knowledge about anything other than what I'm proving. So they don't get the signature value. They don't get an identifier for me as a holder. Zero knowledge proofs, they feel like this really complicated concept, but really what it boils down to is I share what I want to and nothing else gets leaked. That's the goal of zero knowledge proof.
Right. Now that's a very important point, because one of the other myths I hear quite a bit about the use of zero knowledge proof credentials is, oh, you get to choose what the verifier sees. And the second corresponding thing is you can't actually show the verifier the data when they need the data. And I'd like you to briefly talk about both of those. Zero knowledge proofs lets you control or selectively disclose information, but if a verifier needs to know the data with the zero knowledge proof format, can they still get the data?
Oh yeah, they get the data and they get the same assurances about the data, that it hasn't been tampered with and that it was signed by the issuer. They get the same assurances that they get with straight digital signature schemes, but without some of the baggage.
Without the privacy
Right.
disrespecting implications. Okay, so basically they support a superset of what you can do with non-ZKP credentials in terms of what a verifier can get, correct?
Right.
Gotcha. All right, so I think we've established why Evernym and other supporters of ZKP credentials made sure they were there, and why we've implemented that way, and why we chose anonymous credentials, which is Brent, that's based on crypto that originally started where? IBM Zurich Research Labs. How far back does that go?
Oh, it's been around for a long time. It came out of IBM research. Kamenesh and Lisianskia created this signature scheme. It's been used in direct anonymous attestation and EPID. It's been used a lot of different places. It's got a lot of good things, and it's got some drawbacks though.
So it's pretty mature technology, which leads me to my next question and the subject of this webinar. If we've already, if it's specified, if it's been implemented, and Evernym customers have these ZKP CL based credentials in production, why now this interest in a new ZKP format?
Well, if you want to make a cryptographer wince, start talking about RSA. RSA is a really widespread, famous algorithm for signing and for encryption. And over the years, it has been attacked a lot. And in order to maintain security levels within RSA, the keys have gotten bigger and bigger and bigger over time. So CL signatures are based on RSA, which has served us well. It's, there's got some mathematical properties that we're able to take advantage of to do predicate proofs. But the keys are really big and the credential proofs are really big. And RSA in general is widely recognized as something that if you can avoid using, you should probably avoid using it.
Okay. So tell us a story, again, the blog post has the details, but at summary form. So how did BBS Plus arrive on the scene?
Well, from the beginning, we wanted something that was better than CL signatures, but we wanted it to have the same capabilities. So we implemented a pairings-based signature from the start. We use one with our revocation scheme in Indy. That's a pairings-based signature scheme. We were working on rich schemas or schema 2.0. We were working on anonymous credentials 2.0, trying to figure out a way to bring our technology into better conformance with the W3 spec, W3C spec, and better interoperability with LD signature stuff. And so we went searching for a good pairings-based signature. At the time, BBS Plus, it was the clear choice. It was better than the one we had already implemented. We had pretty close interactions with Jan Kamenesh at the time and other cryptographers, and they said, yeah, we don't use that one either. We're using BBS Plus. So we decided to implement it, we being Evernym and the Sovereign Foundation and members of the community. Evernym was primarily in a support role for that one, but BBS Plus, the signature scheme, was implemented in Hyperledger Ursa, and we planned to adopt it. We just said, okay, BBS Plus is there. Now we need to figure out how do we do predicates with it? How do we do better revocation with it? And okay, there's this whole rich schema side that touches on interoperability. How are we going to do all of these things? As folks who've read the blog know, this didn't quite go the way I'd hoped. You know, anytime you spend a year of your life on a project, you want it to go somewhere. Rich schemas was just too complicated. It was hard for people to get their brains around, and it was hard to convince people that all the pieces were necessary, even though they really felt necessary. And even a non-creds 2.0 was trying to do too much.
Yeah. So what was the breakthrough then?
The breakthrough came from somebody else, loving the open source community that we have at IIW. Matter Global said, hey, if we take BBS plus signatures and do things in this way, we can use BBS plus LD proofs, which is an LD signature. And so they tweaked BBS plus to make it more compatible with LD signatures, which was the original goals of rich schemas in non-creds 2.0 anyway. They're, like I said, they're compatible with LD signatures. They support selective disclosure. They do signature blinding. They include an option to do link secrets. There's also this ability to do, you know, linking of any 2 attribute values from different credentials, which is pretty fantastic. Which means even beyond the link secret, if I have a passport and a health credential, I can prove that the same first and last name are included in both credentials, but I don't have to share my first and last name with you. It's a pretty powerful capability. The one thing they didn't give us was predicates. And so we had to, we forced us to do some, you know, introspection and kind of let go of predicates for now.
Right, I know, and your blog post talks about the soul searching that resulted in. So with BBS Plus, the BBS Plus flavor now of verifiable credentials, what are we getting and what are we giving up? Can we sum it up here?
Well, we're giving up predicates. We're getting compatibility with LD signatures. We're getting smaller, faster signatures. We're getting all of the goodness of the original anonymous credentials minus predicate proofs for now. I think that it's going to be possible to introduce predicate proofs as a capability that's compatible with BBS Plus, but we're not going to have that out of the gate.
So that's why we have the asterisk on this chart on predicate proofs. So we basically are giving them up at the outset, but you believe that you and the other you know, cryptographers in the URSA community are going to be able to add that support.
I'm confident that we will. We'll probably focus on revocation first. You know, revocation as it's implemented in Hyperledger Indy is pretty tied up with the way that CL signatures are implemented, and porting that same revocation scheme over to BBS Plus doesn't really make sense when there are more efficient and better ways to do revocation that would be a little bit more compatible with BBS Plus. So the first thing we're going to try to figure out probably is revocation, but yeah, predicates is on the roadmap. It's something that I'm not willing to give up on you.
Yeah, no, that sounds important. It sounds like the advantages of BBS Plus with revocation actually would be another entry on this table that it's going to help us have a, you know, faster, more efficient revocation mechanism as well. Is that right?
Right.
Okay, all right. So I think it's, you know, hopefully this makes it clear. Again, you want to go deeper in the details. Brent's blog post does that. So let's turn to sort of the practical implications, and folks are already asking questions here in the chat. What remains to be done, Brent, to put BBS Plus credentials into full production?
So the BBS Plus LD proofs spec is very much in draft mode right now. It's a pretty complete draft, but it's being worked on at the Credential community group. It's not going to be a W3C recommendation at this stage. It needs to be finished. I think it's close, but the work there still needs to be done. It's done enough that folks have implemented against it and shown that they can be interoperable with it, which means it's really close, but it's not quite there yet. Another aspect, because BBS plus LD proofs enable BBS plus privacy preserving safe credentials to be used alongside other LD signature credentials, we need to look at the ramifications of that. It doesn't make sense to use this privacy preserving safe credential alongside a credential that's perfectly revealing, or at least we need to make people aware that that's happening at the very least. So those are two of the things that I think we really need to hammer out before we can use them. And like I said, we also want to figure out revocation and predicate proofs. Those are big musts from my perspective.
Yep, this sounds, again, I know your blog post goes into more detail about sort of the roadmap from here to full production. So what, and I see I have it on my question list that's already being asked by our audience. What differences will end users see in the move from ZKPCL to BBS plus?
Well, the holders, I'm hoping, and they shouldn't notice much of anything. They're getting a credential. They've gotten credentials before. We intend them to be able to use all of their credentials moving forward. So holders shouldn't notice much of anything. Verifiers hopefully will notice that things are a bit smaller, that they can do things more quickly, that they have access to this greater semantic meaning. Right now when you share a CL signature anonymous credential, the verifier essentially kind of has to know what the issuer was thinking. So it requires some assumptions to know what the meaning of the different attributes is. The LD signatures aspect of BBS plus LD proofs allows verifiers and issuers to share that semantic meaning via the credential and via the schemas that are used for the credential. Issuers are going to have a little bit less setup before they are able to issue credentials. But for the most part, we're hoping that by adding support for BBS plus as an additional format supported by Evernym's Verity platform, it'll allow issuers and verifiers to transition pretty seamlessly without giving up on the existing signatures. I don't anticipate every CL signature based credential is going to have to be reissued. I don't think we're not anticipating that. We're not planning for that. We're planning for them to be able to be used with the new format and with the new scheme.
So we'll be adding support for BBS plus credentials, but not taking away support for. And then, so that means issuers can pretty much seamlessly just transition across, and their holders you shouldn't notice anything. And provided verifiers have the software to verify that format, they too should have a pretty seamless transition. Is that right?
That's the plan.
Okay. So last question before we jump into the audience questions. So what, if others in the audience are agreeing, yeah, it sounds like BBS plus is a pretty good idea. How do they get on the bandwagon? What do they do to get started?
Well, check out the blog post if you haven't already. Go find the BBS plus LD proof spec. It's in GitHub. I'm sure we can share the link to that. Give it a read. Give some feedback, raise some issues, help that get to completion. If you have funding for some cryptography work, send somebody to URSA to hammer at the BBS plus implementation there. I have faith that it's a pretty darn good implementation. It's very faithful to the specification, but the more eyes that you can have on a cryptographic key component, the better. We want to know its flaws. We want to know where it's going to break, and look at in your own organizations what it would take to move to BBS plus and support it yourselves. So that in addition to Evernym and Matter and a bunch of other folks that, you know, we can all interoperate, not just with a data model, but with a signature scheme.
Yep, that sounds great. So Andy, I think it's time. I know the questions are stacking up hot and heavy as they always do. So let's turn it back over to you to start curating the questions. Yeah,
thanks, John. Can I just say, guys, I really enjoyed that. I thought that was epic, really good. So thank you very much indeed. I'd just like to come back quickly on that question about what difference will end users see. And I think there is quite an important difference lurking in there, which is at the moment, if you use Evernym's Connect Me app, for example, there's no control over the order of the attributes that are listed, right? And you're seeing the attribute names, which could be quite obscure. And you know, the verifier doesn't know if a date is meant to be year, month, day, or day, month, year, that kind of thing. So you are getting kind of service decorators with this new approach, right? That allows you to control that kind of presentation layer. Would that be right?
Yeah. So getting a little technical, right now the list of attributes for an anonymous credential is a JSON array, which means it's a list of strings. That's all it is. Using BBS plus LD proofs, we'll be able to take full advantage of any JSON-LD schema. Schema.org has hundreds of them. As long as it can be described in JSON, we can issue a credential based on it now. It's pretty fantastic. And on top of that, like you said, we can layer attribute ordering information and things like that.
Yeah, and I think we've had feedback from live projects like with the National Health Service in the UK, for example. They want to see the name and maybe their employee ID at the top of the credential, not some strange base 64 hex kind of thing. So being able to put a nicer user interface on it, I think, is a huge leap forward from just a flat structure where the actual attribute names are revealed. So I think at the technical level, there may not be much impact for users, but at that presentation level, I think it's going to make things much more user-friendly for people.
I think it's going to enable a similar transition. Those of us who are old enough to remember the move from Web 1.0 to Web 2.0, it's going to be a similar paradigm shift, in my opinion.
Yeah. Loads of questions coming in, so keep them coming, folks. We'll cover as many of them as we can do, including the really awkward ones that we can hammer the guys with here. So, okay, let's do this one from Hakan. Hey, Hakan, thank you for this. Why is it an important feature that the issuer signature is non-correlated? I mean, their DIDs are publicly available on a ledger.
Right.
All right.
The issuer did. You have to know who the issuer is. That's a given.
Yep.
Every time an issuer signs a credential, the credential that's issued has a different signature. So even though it's the same DID, the signature value is going to be different for every single credential. So which means not only is the verifier going to know who the issuer is, but they're going to know it's this specific credential that was issued. And every time I share that credential, if I don't have a way of blinding that signature, it's going to correlate me across every verifier and even back to the issuer. Right now with anonymous credentials and moving forward with BBS Plus, even the issuer doesn't know what the final signature looks like.
Right. And whilst the issuer has a public DID on the ledger, what they're signing the credentials with is a different thing completely, really, isn't it? To what's on their DIG. So you got the credential definition with signatures, with verification keys in it as well. And you got the peer DID with that individual person as well, plus the link secret, right?
Right. So BBS plus LD Proofs does that a little bit differently. They BBS plus Signatures gives us the capability of dynamically generating in a hierarchically deterministic fashion the set of keys that are used for verification. So we don't need to store a big old cred def on a ledger somewhere for people to refer to. The issuer
Right.
can say, here's the seed that you should use to derive the public keys that you can use to verify it. So it's much smaller kind of infrastructure requirements.
Right, interesting. Okay, let's crack on with another one here. Right, well, this is a bit like related to link secrets actually, but what kind of options are available to make sure that attributes in a compound proof are talking about the same person versus just the same holder? For example, proof of age from a driving license and proof of education from a college certificate.
So the link secret is one, binding mechanism. Another one that we mentioned was you can prove that any two attributes are the same without revealing them. So if the credential, you can issue a credential using BBS Plus to a customer identifier or to a passport number or to a social security number. And if that number is duplicated in multiple credentials, I can prove that. I don't have to share it, but I can prove it. And so in that way, you can also do linking between credentials.
And Brent, can that also extend to proof of matched biometric?
I don't see why it couldn't, but I'm not an expert in biometrics and matching, and I know that there's some fuzziness there. And so I'm not sure exactly how the fuzziness would play with the math.
And you could put the holder's photo in both credentials, right? And then the verifier can match both of those if they ask for them.
Right. If you have if it's an identical photo, yeah. So two different photos of the same person would require some processing, and we haven't sorted out exactly how to do that, obviously. But yeah.
Yeah. It's actually worth pointing out the IATA Travel Pass program does use selective disclosure in it. It uses zero-knowledge proof signatures and it uses compound proofs as well. So this isn't kind of pie in the sky stuff. It is live at the moment. Mm-hmm. Here's a question from Robert Celeste. Hey, Roberts. What is privacy respecting revocation? I love this topic.
So the simple way to do revocation is for an issuer to go, here are the identifiers of all the credentials that I've issued that I have revoked. And as a holder, I would have to take that unique number, share it with the verifier, and the verifier goes and looks at this revocation list and goes, okay, good, you're not on the list. A privacy respecting revocation scheme means I can prove I'm not on the list, but I don't have to show you the number.
Right. So what are we trying to protect against here? It's the verifier having to contact the issuer or being able to correlate, right?
Both. Yeah. We want to reduce as much as possible any need for the verifier to contact the issuer. And we want to not have a protocol or a scheme that requires correlation. Yeah.
Yeah. And I actually just see this, Andreas, in the chat, to avoid track and trace. Yeah, absolutely right. If the issuer can see everything you're doing, then it's not very private. So right. You need to be able to have the issuer revoke a credential without the verifier having to speak to the issuer, because also the issuer may disappear as well. That's another thing, isn't it? Maybe Drummond on this one. If the issuer is destroyed in a war or goes bankrupt or something, you might still have a credential which might be your university degree. It doesn't make your credential invalid because the issuer is not there. So you still need to be able to verify that credential, even if the issuer doesn't exist. So you don't have to contact the issuer at any point, Drummond, do you really?
Well, yeah, you've hit the two key points, Andy. There's the privacy issue of what's broadly called the phone home problem, right?
Yeah.
And I have heard, for issuers that are or for formats that require issuing to a public DID, the assumption is you're issuing to public DID. And then it's brought up, well, that's now you're going to have the correlation of that DID everywhere it's used. The answer has been, oh, well, we can issue a new version of the credential each time you need to use it. And now you've just inverted the problem. Now you're phoning home every time you're issuing the credential. So neither one of those I think is adequate. But you also bring up the second point of when there is a fully verifiable signature that doesn't depend on having to go back to the issuer, you've got a lifetime credential, right? You're not limiting it to the issuer still being around.
Yeah, and that's what you have with your birth certificate, right? You have a printed birth certificate. As long as you don't lose it, right? You carry it with you, and you can always verify. You show it, in, albeit it could be photocopied, etc. But we all have these things, and we carry them with us. And even if whoever it was issued the birth certificate is destroyed in a war or disappears, you still have the physical things. This is a digital equivalent of that. All right, here's a good one from Anon, who is retaining their privacy. What are where are compound or aggregate proofs composed within the wallet? Question mark. Brent, where are these compound proofs created?
They would be created by the holder in response to a proof request or a presentation request from a verifier. So the verifier composes basically a set of acceptable credentials or attributes they want to see from specific credentials, and they say, okay, this issuer, this type of credential would be acceptable. Show me these 5 attributes. Plus, from this other issuer, these attributes. If you show me all of those things, then I have what I need. The holder gets that, and interacting with their wallet composes a compound proof based on the credentials they actually hold.
And that's all done bang in real time, right?
Yeah, with BBS Plus, it's quicker. The CL signatures isn't bad for the actual proof generation. It's the keys and the sizes of things that get out of hand there. But yeah, it's quick enough that it can happen in real time.
Yeah, so in with Connect Me that supports compound proofs already, the Evernym mobile app, it does create a compound proof, in under a second and send it off. I think the more attributes you get, the more credentials, it takes longer to do all the calculations, right? So generally asking for fewer attributes you ask for, the quicker it's going to be. Here's one from Swapna. Hope I've got that name right. Is it possible to choose the type of signature one can use to sign the credential or sign the proof? Oh, that's a nice one.
As an issuer, you need to, there are some pre-set up things that you need to do. With anonymous credentials, you need to generate a credential definition, which is a whole bunch of randomly selected prime numbers. With BBS Plus, you need to choose the initial value for those deterministically, hierarchically deterministic key generation there. So there is a bit of setup. And so the issuer does need to choose in advance what signature they're going to use before they issue a credential. The holder gets what they get. They don't have a lot of option there. Once they get a BBS Plus LD proof credential, they're not going to be able to, get a different one. And I mean, without the issuers explicitly supporting that.
Yeah, cool. Thank you. Lots of stuff being answered on the fly in the chat as well. So thanks for those folks who are doing that. Just trying to keep up here. So normally we go a bit after the hour, by the way. So we've got 5 more minutes till the hour. John and Brent, you okay to just do another 10 minutes after that? So
yeah, it sounds good.
Cool. Okay. Here's one from Timo Glastra. Hi, Timo. What's the role of Indy going to be with BBS Plus support for Evernym? BBS Plus signatures are broader than the Indy ecosystem, so I'm curious what the role of Indy is going to be when we have JSON-LD BBS Plus credentials. Is Indy just going to be doing revocation and DIDs? What's that one?
I'll take a stab at it. The primary function of Indy, as I see it, is to support a distributed ledger that has some some good oversight. But it's all ledger stuff. So BBS Plus removes some of this reliance on the ledger. Our initial round of BBS Plus signatures, we're not going to have a revocation story built in. We don't have predicates, and the signatures don't require a credential definition on the ledger. And so beyond the issuer being known by a DID, there isn't much that the ledger needs to be involved with for BBS Plus. So what I anticipate is there will probably be an indie hype that says this generic BBS Plus LD proofs, you can sign anything with that. How are we going to use them safely in a way that's compatible with the priorities and things that the indie community cares about. So I think there will be a hype that defines some of those things. And in addition, I expect there will be an Aries RFC that says, here's how the Aries community wants to use these, even independently of indie. And I expect all of those things to really just be, here are the specific ways that we are going to be, as a community, compatible not only with each other, but with the broader uses of BBS Plus LD proofs.
Yeah, got it. So in fact, Drummond, I don't know if you can chip in here on you're reducing the dependence on or opening up to allow for multiple ledger support, I guess, because we're seeing ledgers popping up for all sorts of things at the moment, aren't we? And people shouldn't have to worry about that.
Exactly. I think that's the point, Andy, is there has been in the evolution of, verifiable credential space, a pretty close, they call it dependency of wallet and agent implementations on specific ledgers and formats. And so I believe, and I want Brent to validate this, that moving to a format like BBS Plus and knowing, what we've learned so far, is this going to, Brent, take us in a step of greater ledger independence, the BBS Plus credential format?
I believe that it will. Right now, anonymous credentials depend pretty strongly on Indy because Indy has the transaction types that can be stored there, our credential definitions and the revocation registries. Moving forward, BBS Plus requires less reliance on a ledger, and the things that it does require of a ledger can be done a little bit more generically. So it's something that's much easier for multiple ledgers to support in the same way that the existing non-creds we probably couldn't do.
So would you say that would apply to non-Indy ledgers as well? Ethereum or Ion or new ledgers that are new DID methods that are occurring. We're now, as you know, as co-chair of the DID working group, I think we're going to pass 90 registered DID methods. We have passed 90. Okay.
Wow.
Yeah. As that spec has gone to candidate recommendation, folks are like, hey, I want to get in the door before it gets final. You'll still be able to register after that, but folks want to be sort of part of the original party. So Brent, do you think BBS Plus credentials there'll be a wider set of DID methods that can support them?
Yeah, I see no reason why they couldn't be supported by any existing DID method.
Very interesting. Kerry too, says Paul Graham. Hey, Paul. Kerry,
I'm just going to jump in there.
Is that another webinar?
I think that's another webinar. I want to say, yeah. I'm going to channel Sam Smith here and say, of course, any key format you want to use, Kerry can also support. Kerry is not it's not a specific cryptographic algorithm or signature algorithm. It's a whole architecture but that is another webinar.
That's another webinar. Actually, maybe Alex, could you put on the list? Let's have a Kerry webinar. Kerry, by the way, the acronym Drummond means?
It means key event. What's the R? Key event. Key event. Resource infrastructure. I think it's, in any case, it's a whole architecture for
self-certifying.
Self-certifying identifiers and the corresponding key management, which makes it the most decentralized to my knowledge, of all of that. I'll put in a blog that the book on self-sovereign identity that I'm a co-author of the last 2 years' work is going to come out in April, and Sam Smith has written an entire chapter on Kerry in there, so lots more to come on that.
Yeah, and Antti Katunen in Finland to the rescue there. Key events receipt infrastructure. I'm sorry to put you on the spot there, Drummond. I don't normally do that.
You'd think I'd remember that, but
yeah, let's have another webinar. I was going for rotation, but anyway, anyone else who wants to invent some more acronyms, please feel free and chuck them our way. We'll just do another couple of questions before we close off. There's two actually on link secrets. One's from Oliver. Hi, Oliver. Another one is anonymous. But what happens to link secrets with BBS plus signatures? I mean, link secrets are mysterious enough. They get more mysterious. What's happening, Brent?
Well, the way that BBS plus LD proofs describes holder binding in a privacy preserving way, they don't use the words link secret. They talk about BLS public keys and private keys. There's a key feature about BLS keys is that once I have my private key, I can reveal any number of different public keys for that private key, which is what a link secret is and does. So it's an identical mechanism cryptographically and mathematically. It's got a little bit different terminology around it, which actually helps us when we're trying to explain these things to to folks who know. What BBS plus LD proofs does is it describes holder binding that is either privacy respecting or not. And so, one of the aspects, in my opinion, that we need to, make sure of as we move Indy into a position to use BBS plus is to, state rather emphatically that we're going to use the privacy preserving mechanism rather than the non.
So the same function is being achieved, though, right?
Right.
With them, albeit possibly in a different way. Okay, let's do maybe one last one. Okay, so timeline. So Timo Glastra is saying, what's the expected timeline for BBS plus support in Evening products? Well, first of all, I just want to say that Evening products were all in on BBS plus and adjusting roadmaps and all that kind of thing, as you might expect. But I think there's probably a question before that, which is what's the timeline for BBS plus and this kind of standardization stuff you described, Brent? It feels like it could be, quite a complex thing to get to the point where we've got some standardization, interoperability here. But is it that, or is it actually happening much quicker than that?
It's happening pretty quickly. I know from Evernote's perspective, I'm not a product guy, and every time I invent timelines for things, people wince and cringe because I'm terrible at it. I know that we want these capabilities as soon as we can get them and as soon as we can figure out how to do it safely. So definitely this year we're ramping up engineering resources to begin implementing all that we can now. So we're starting to work on it now, and as soon as we have it done, it'll be done.
Yeah. And what about the the standards body side of things and
like I said, the LD proofs draft spec is in a really good state right now. There are still a few answers here and there. The more folks who are able to give it a read through and raise questions about it, the faster that can go. The faster we can end up with something that a lot of people can agree on.
Yeah.
And just to clarify there, Andy, the part of the benefit of BBS Plus is that the format will be compatible with the W3C standard, right? The verifiable credential specification. So what we're needing to standardize is, okay, let's agree on the signatures, how they're applied to LD, so that so that it's actually interoperable. It's not just compliant with the W3C spec. Is that right, Brent?
Right. I mean, the W3C spec was a labor of love. It was a lot of hard work. There was years and years of consensus building to get it out the door. And even with all of that, it really is just the first step toward potential interoperability. Multiple organizations and implementations of that same specification are not going to be able to interoperate without what we're doing now, which is trying to establish some more practical interop, and agree on some signature suites that we can all be comfortable with.
Yeah, so there's a few steps to go, but I think what we're seeing is a meeting of minds, right, isn't it? Because it feels, from my kind of layman's perspective, that we've got a sweet spot here. We've got a lot of the beauty of things like selective disclosure, zero knowledge proof, not revealing issuer signatures, compound proofs. Plus, we've got the service decorator side of things that makes it easier to use and put context and structure around it. So that's my kind of reading of the non-technical side of things. It's a much more usable evolution of digital credentials that will take it to the next level. Would that be about right then, do you think?
Yeah, that's why folks are so excited about BBS plus LD proofs. That was the immediate reaction at IAW was, from the JSON-LD and the LD signature side was, oh, this is something we can use. And yeah. From the Evernym Indie anonymous credential side, we were like, this is something we can use. It was both sides seeing the same thing and going, yes, let's do this.
And Andy, I think it's worth pointing out, and that's why the title of Brent's blog post is I would say the strongest advocate for the privacy preserving credentials and the work on ZKP to begin with. We saw the same thing that I think Matter and others did when they published that at the last IAW, when it was every 6 months, so it's moving fast, that this now could bring the ZKP and JSON-LD communities together, and that convergence could really help us with this question of overall interoperability without, most importantly, without giving, the JSON-LD folks didn't want to give up all the semantic richness and other work on JSON-LD, but we didn't want to give up. And I say with digital health credentials and digital travel passes, we are absolutely seeing the requirement. You must have that privacy preservation. There are already enough issues around it. So,
so we're seeing that. We're seeing that again and again, aren't we? As people get into the detail, they go, "Oh yeah, we've got to make sure this is has privacy built in." And on that topic, I think we'll wrap now. I'm just amazed so many people, well, I shouldn't be amazed because it's awesome content, but we've still got a whole bunch of people on. There's a whole bunch of questions as usual, we couldn't get to, but thank you for asking them anyway. Your contributions are great. It really helps us to see what people are thinking about when they ask these questions as well. A couple of things just to let you know about. So the Internet Identity Workshop number 32, and Drummond will tell us he's been at all 32 of them, is on April 20th to 22nd. So 20th to 22nd of April, IIW. There's a session there, convergence on BBS plus verifiable credentials. Who would have thought that was happening? So please go and attend that one, and you get a lot more detail on it. Also, we've got our next webinar coming up that is on the 14th of April on Privacy by Design with Dr. Anne Kabukian, which should be a cracker. So please come along for that as well. Thanks for everyone who's attended. Special thanks to Brent for being awesome as usual, and Drummond for being equally as awesome. Perfect stuff. Thanks very much. Have a great weekend for those who have the day off tomorrow for Easter Friday. And enjoy yourselves, and see you later. Thank you very much indeed.